Hello everyone, welcome back to the channel. So today we are doing Leetcode 3195, find the minimum area to cover all ones, part 1. So let's have a look at what the problem statement says. It says you're given a binary array known as grid. Now what you have to do is find a rectangle. Obviously if you're finding a rectangle, it's going to have vertical and horizontal sides. So find a rectangle with the smallest area such that all the ones which are in the grid, all the ones which are in the grid lie inside that rectangle. So for what you have to do is you have to make a rectangle basically in very simple words, and through that rectangle you have to enclose all the ones. In very simple words, make a rectangle such that it has the smallest possible area, and this is one condition, not a condition but sort of something that you have to aim for, the smallest area. The condition is that it should enclose all the ones that you have in the grid, right? Return the minimum possible area of such a rectangle. So for example, if I talk about this test case first, this is the second test case that we have. Now what I could do is I could have this as a rectangle with an area of 2, right? I could have this as a rectangle. This is actually a square, but every square is a rectangle, right? This has an area of 4. I could have this as a rectangle, right? This has an area of 2. But the smallest one that I'm going to get is this particular. Although this is a one by one square, but we are calling it a rectangle for now. So this is the smallest one that I'm getting. I have created a rectangle which has an area of 1, and it successfully encloses all the ones that you have in the grid. So the overall answer for this test case is 1. Now if I take a look at this particular example test case, then does this rectangle enclose all the ones? It does not. Does this rectangle enclose all the ones? It does not. Neither does this particular rectangle. So what I really have to do is I have to create this particular rectangle, right? So in order to enclose all the ones that have been given to me in the grid, I literally have to cover all the elements inside of the grid, right? So the answer for this test case is equals to 6, 2 by 3. Very simple, right? So now if the best way to think about this particular problem is that you take a very random test case, a very random test case. So what I have done is literally taken a random 5x5 matrix and just plotted random ones, right? You could do it anyway. You could make a 6 by 6 or 7 by 7 grid, and then just plot random ones at random corners or in the middle, or any way you want. Now the first thing that I would observe is I need to enclose all these ones, right? This is 1, 2, 3, 4, and the fifth one. I need to enclose all of them, and what I'm observing is that 3 is sort of lying in the middle of this. So one thing I'm 100% sure: rectangle has very specific corners, right? It has 4 very specific corners. So it's going to start from a certain row, let's say row S, and it's going to end at a certain row, let's say row E, row starting, row ending. Similarly, column starting and then column ending. Now, my question is, which element decides these 4 things? Row starting, row ending, column starting, column ending. Obviously, what I'm trying to suggest is that I do not have a concern with all the ones that are given in the grid. No, it's very visible to me that the only ones that I am concerned with are the boundary ones, are the ones which are at the boundary of the grid, isn't it? So I am interested in the topmost one, the leftmost one, the rightmost one, and the downmost one, isn't it? Because I'll have to start from here and go till this one, and then go till this one, and then of course I'll have to reach this one as well, isn't it? And that's how I'm going to make my triangle. I am not concerned with this because this is automatically going to be covered. It's not lying at the boundary. Now if my test case if it was a little different, for example, let's say that I had a 1 over here as well, then in that scenario what I would have had to do is not stop at this point. So I start at this one. when I start at this point, I 100% know for a fact that okay, I'm going to go till this one, and I'm going to go till this one. But on the downside, this is not where I stop, because I still have to cover this particular one. This is where I stop, right? This is how I cover all of them. So ultimately, what I'm interested in are the boundary coordinates, right? Now, if we think from a coding perspective, from a code point of view, then how do I actually know who is the rightmost coordinate? I am just interested in the coordinates, right? Not the points themselves. I'm just interested in knowing who's the rightmost one. So what I will do is, if I'm interested in knowing the rightmost coordinate, this is the rightmost coordinate, right? What I'm actually interested in is the biggest column, is the column ending, which means biggest biggest j value, isn't it? Similarly, for the leftmost, I'm interested in the smallest value of j. Correct. For the topmost, I am interested in the least value of I. So basically, the least value of row, isn't it? I what I is row, j is column, and similarly, downmost is the biggest I. You can say the biggest column. Oh, sorry, the biggest row. So these are only sort of, you can say, the four variables that I need to take into account. And once I have them, at the end, what am I going to do? So in this scenario, let's change this back to 0. Let's change this back to 0. Okay, perfect. Now, once I have these coordinates, I know for a fact that the least I that I have is 0, and the biggest I that I have is 3. What do I do next? This tells me that you have 4 rows to cover. So basically 3 minus 0 plus 1. Biggest I minus smallest I, and plus 1 I am doing because we are starting from 0. So these are actually 4 rows that I need to cover, and not 3 rows basically. Similarly, what I'm going to do is, in order to calculate the area, I'm talking about area calculation over here. Okay, I'm talking about area calculation. Do I know the biggest j? Yes, 4. Do I know the smallest j? 0. How many columns do I have to cover? 5. So 4 minus 0 plus 1, and I'm just going to multiply these two numbers. So 4 into 5, what does it give me? 20, and that is actually the correct area as well, if you think about it. Right, 4 into 5 is 20. So that is exactly what I'm going to do inside my coding environment as well. Let's see how we can do this. What I'm going to do simply is take a big I sort of variable, and since I am going to be maximizing this value, right? I am going to be maximizing this value, so I can take it as -1, a negative number, right? Perfect. Now, if I talk about a small I, sorry, I am going to I am perfect. I am going to be maximizing this. And when I talk about the small I know for sure, I know for 100% that I'm going to be minimizing this, because I'm sort of saying what is the minimum I that you have? What is the minimum I that you have? So small I is actually going to be int max. All right. I could have just initialized these variables beforehand, but it's very important for you to know why I'm taking one as -1 and why I'm taking the other one as int max, right? Similarly, I am going to take a big J and a small j. Perfect. Then what do I need to do? I just need to sort of traverse on this particular grid, or let's say this particular grid, and when I stumble upon any particular one, I just need 4 conditions. I need to check whether it's the rightmost, whether it's the topmost, whether it's the downmost, or whether it's the leftmost, and I need to check all of these 4 conditions for all of the ones that I have, because anyone can be the rightmost, anyone can be the, the downmost. So the simplest way, not complicating things, the simplest way would be that you check all these 4 conditions against everyone. Not that much of a sort of, if I look at the constraints, then the constraints say at maximum you're going to have a grid of 1000 by 1000, right? So 1000 by 1000 into 4, it's not that big of a time complexity. So you can very easily, what I'm trying to say is you can very easily afford to do that, right? J equals 0, j is less than m, and j plus plus. Now what exactly are these n and m that I have written over here? These are basically rows and columns, right? So grid dot size means rows, and columns are grid of 0 dot size. So grid of 0 dot size means how many elements do I have in the first row, right? And basically how many elements I have in the first row means the number of columns, right? Now, if grid of ij, if the current number that I'm on, if it's equals to 1, then what I need to do, I need to check the four conditions. I need to check the four conditions, and those four conditions are basically this. So big I is going to be the maximum of what it already is, or the current I that I'm on. Similarly, small I is going to be minimum of what it currently is, or the current I am on, right? The same thing I need to do for j as well, right? I need to check big j, similarly j, 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 and j, right? So what I'm doing is I'm finding out the starting column, the ending column, and similarly the starting row and the ending row. In the end, just like I said, what are we going to do? We are going to return this particular thing, right? Perfect. So what I'm going to do is I'm going to say, okay, big I minus small I, what's happening? Small I plus 1 multiplied by big J, what's happening? Wait a second. Um, big J minus small j. My keyboard is for some reason not working correctly. And if I now submit this, let's see if it works. Right, it passes the example test cases, and if I submit this, let's see if it passes all the other test cases as well, right? And it very clearly does. Now, if we think about the time complexity of this particular code, then in the worst case, the time complexity is what? And let's say that I have a grid of 1000 by 1000, right? So what I'm doing is I am visiting each and every element once. So you can say O of n square, right? Because obviously it's a 2D grid, so we'll have to do O of n square in order to visit everyone. Everyone means every single one that I have, one digit, right? And when I encounter a one, let's say all the elements in this particular grid are one. So what I'll be doing is at each and every single one, I will be checking these four conditions, and these basically four steps. So again, since these are just simple lines of code, they sort of mean O of one operation, right? So the overall complexity over here is O of n square, the time complexity. And if I talk about the space complexity, I'm not taking any extra space, I'm just taking these four variables. So that accounts to a constant space complexity, O of one space complexity, right? So I hope you found the video helpful, and I will see you in the next one.